Alright, we're ready for 2.5, writing and graphing compound inequalities. So the word compound means multiple. There's more than one thing going on here. So one of our compound situations is going to look like this when we graph it. So there's two parts to it. X is greater than -2, greater than or equal to -2, but it's also less than or equal to 1. So when there's two endpoints and the solution is everything in between them, that's what we call the and situation. It's an intersection. So it has to satisfy, it has to be greater than -2 and less than or equal to 1. And this is another way to write it. This is actually a more succinct way to write it. How you do the intersection kinds, the ones with and that look like this, is the left-hand target goes on the left, the right-hand target goes on the right, X goes in the middle, and both of these are less than or equal to, depending on if the circle is filled in. Alright, the other situation you're going to run into is one that looks like this. So either X is less than or equal to -2, or X is greater than or equal to 1. And like I said, this is an or situation. There's no way it can satisfy both of these situations at the same time. So this is a union. It's called a union because it's either here or here. And this is how you write it. There's no really easier way to write that. So let's look at some examples on how to solve these. So let's say I have a compound inequality that looks like this, and I know that this is an intersection so that when I graph it, it's going to look something like this. So let's just pretend that this is all we have. I know that to get X by itself, I need to add 2, right? Well, if I add 2 to this, I have to add 2 to everything. So now instead of just the left and the right, I have 3 parts that have to have 2 added to it. So let's go ahead and do this. -4 plus 2 is -2. The less than doesn't change. X is by itself. And 3 plus 2 is 5. So if we were to graph this on a number line, 5 is that one. So let's see, 2, 1, 0, -1, -2 is there. The circles are open. And it's everything in between. Because it's an intersection. It's an and situation. Okay, here's another one. The first thing I'm going to do is I'm going to isolate this term, so I'm going to subtract 1 from everything. When I do that, this is -4. What I have left over here is -2x. And is less than or equal to 9 minus 1 is 8. Well, I still need to isolate x. I need to get x by itself. So in order to do that, I have to divide by -2. That means I have to divide everything by -2. And don't forget, when we're dividing by a negative number, all the signs change. X is by itself in the middle. 8 divided by -2 is -4. -4 divided by -2 is 2. And then let's look at the way this is written. It's really not natural to have the lowest number on the right-hand side. So I'm just going to flip everything around. And when I do that, this becomes less than or equal to. This becomes less than. This would not, I wouldn't count you off on a test if you did this, but this is really the more correct way to write it. Okay, so what do we do now on an or situation? We're just going to solve each one of these separately. So on this one, I would have to add 5 to both sides. This would be -3, and this would be 3x. And then I'd have to divide by 3. which leaves me on this side with x is less than -1. Now let's go ahead and solve this side. Add 5 to both sides. And 2y. I'm going to divide both sides by 2. And I am left with y is greater than or equal to 3. Or this should be an x. I don't know why those are wrong. Let's change that to an x. Keep our variables the same. Alright, let's go ahead and graph this on a number line. There's 3, 2, 1, 0, -1. So either x is less than 1, the circle's open because it doesn't say or equal to, or x is greater than or equal to 3. And this is what our, oops, I'm sorry, that's what our solution would look like. Because this is an or situation. Alright? And then, just a note, we are skipping 2.6. You don't have to do 2.6. And you're done with chapter 2.